Welcome to the Graceful Grammar Higher Secondary School. Grade 8th Subject Maths Book MATHSWISE based on the Pakistan NATONAL Curriculum, 2006.
Fatma and Aiza both like playing Ludo and reading books. We say that their sets of hobbies are overlapping. Fatma and Zainab do not have any hobbies in common. We say that their sets of hobbies are disjoint. Two sets A and B are said to be disjoint if they have no common elements. In other words, A intersection B is equal to an empty set or null set. Let's look at an example. Suppose we are given these sets of numbers. Set A contains the numbers 2 and 4, while set B contains the numbers 6 and 8. Since they have no common elements, their intersection is a null set. So these sets are disjoint. Two sets A and B are overlapping if they satisfy two conditions. At least one element is common to both sets, and neither is a subset of the other. Consider these sets of numbers. Set C contains 2, 4, 6, and 8, while set D contains 4, 8, and 12. Observe that elements 4 and 8 are common to both sets, so that C intersection D contains these two elements. Further, C is not a subset of D, since some of its elements are not in D. Similarly, D is not a subset of C either. Therefore, C and D are overlapping sets. Are sets B and C overlapping? Let's recall the two conditions for overlapping sets. Sets B and C have two elements in common, 6 and 8. This satisfies the first condition of overlapping sets. However, set B is a subset of set C, since every element of set B is also an element of set C. This does not satisfy the second condition for overlapping sets. Hence, B and C are not overlapping. Now, try to solve these problems. Let's look at them together. Set X contains the numbers 1 to 4, while set Y contains 0 to 3. They have three elements in common, 1, 2, and 3. Neither is a subset of the other, so they are overlapping sets. Sets S and T have no elements in common, so they are disjoint sets. Sets L and M have two elements in common, 3 and 5. They cannot be disjoint sets. But set L is a subset of M, so they cannot be overlapping sets either. Therefore, sets L and M are neither disjoint nor overlapping sets. To summarize, sets A and B are disjoint if they have no common elements. They are overlapping if there is at least one common element, and neither set is a subset of the other.
Set E has 1, 2, and 3 as its elements, and set F also has 1, 2, and 3 as its elements. Since they have the same elements, we can say that set E is equal to set F. Now consider two other sets. Set G with 3, 9, and 11 as its elements, and set H with 11, 3, and 9 as its elements. we can see that both the sets have the same three elements 3, 9 and 11. So set G is equal to set H. From this example, we could say that as long as the elements in the sets are the same, the order does not matter. Now look at these two sets. Set I consists of 4, 5 and 8. Set J consists of 4, 5, 8 and 9. If you observe, you can see that both the sets have 4, 5 and 8 as their elements. But J also has 9, which set I does not have. This means that I is not equal to J. Remember, for sets to be equal, their cardinal numbers also have to be the same. In this case, n of I is not equal to n of j, which makes the sets unequal. When I say precisely, this is what I meant. Same elements and the same number of elements. Now look at these two pair of sets which are equal. Cardinal number of E is equal to the cardinal number of F. Cardinal number of G is equal to the cardinal number of H. Remember, two sets that are equal will always be equivalent. Now look at sets E and H. They are equivalent, but since the elements are not the same, they are not equal. But now look at sets E and F. They are equivalent, but they are also equal. This tells us that two sets that are equivalent may or may not be equal. Remember, two sets are equivalent if they have the same cardinal number. And two sets are equal if they have the same cardinal number and the same elements.
Alright, so this video we're going to look at sets, and we're going to talk about union, intersection, and complement. Alright, so let's talk about what each one is. If we're given a set A and a universal set U, the universal set is the set that contains everything. Okay, and the set of all elements of U that do not belong to A is called the complement of set A. And the way we write it is with this A prime here. Okay, so basically, if you have a universal set U and you have a set A, and A has some elements in it, well, every element that is not in this one in A but is in the universal set, that's the complement of A. And I'm going to do some examples. So I got about 8 examples to work. Alright, so and then we have the intersection. So given two sets A and B, the set of all elements that belong to both sets A and B is called the intersection of the two sets. And this is how we write it: A intersect B. And then the set of all elements belonging to set A or to set B or to both sets is called the union of the two sets, and we write it like this: A union B. So intersection is basically, if you want to find the intersection of two sets, it's the elements they have in common. And the union of two sets, so if you have two sets and you want the union, it's just every element that's in both sets combined into one set. Okay, so let's go ahead and get started on the example. So you can see I've got 8 examples to work. Alright, so let's look at this. So we want to find the complement of A. Well, here we have the universal set. So the universal set contains the set of numbers of the numbers 1 through 10. Here's set A, 1, 3, 5, 7, set B, and set C. Alright, so we want the complement of A. So the complement, remember, the complement of A is all of the elements that are not in set A but are in the universal set. So you see how set A contains the numbers 1, 3, 5, and 7. Okay, so if you see that, see 1, 3, 5, and 7. Those are the elements. Go ahead and write it down. So the complement of A is equal to, so remember that's going to be what? 2, 4, 6, 8, 9, and 10. So there's the complement of A. Make sure I got everything. 1, 3, 5, 7. 1, 3, 5, 7. So, yeah, that looks right. All right. So now I want to know, what does A complement and B have in common? So here's A complement. Here's B. Well, let's underline the numbers they have in common. So let's see. They've got a 4 in common. Okay. They've got a 6 in common. And they've got an 8 in common, and they have a 10 in common. And so those are the values they have in common. So this set would be, let's see, that's going to be what? 4, 6, 8, 10. And so there's A complement intersect B. All right. All right. Now let's look at the next one. We've got A intersect B union C. Okay, A intersect B union C. So what we're going to do here is, notice that this is in parentheses. So we need to do this first and then do the intersection with A. Okay, so first I need to find B union C. Okay, so that's all the elements from B and C combined into one set. That's what union means. So we've got a 2, 3, 4, 5, 6, 7, 8, and 10. That's all the elements from both sets combined into one. And yes, they both have a 4, but you only write it once. Don't write it twice. Okay, so there's B union C. So what I want to do is I want to take this set here and intersect it with A. So I need to know, what elements does this set and this set have in common. Okay, so let's see. Well, let's underline